So hi everyone, welcome to the new edition of vCluster Friday. Today we have the awesome team behind Sveltos, and we have Colin and Luca from the team. So Colin, if you want to go for an introduction.
Sure. My name is Colin Lacy. I'm a software engineer in the hardware organization at Cisco. And I've been, just making YouTube videos about Sveltos for a little under a year now. And one of my favorite open source projects.
Luca.
Hey, yeah, I'm Luca. I've been working on Kubernetes since 2018 now. I was at Tegera working on Project Calico, and at Cisco working on different Kubernetes projects, and I'm one of the maintainers of Project Sveltos.
So I'm Hrittik, and I'm your host for this stream for vCluster Friday. I work at vCluster, and I'm a CNCF ambassador as well. So this edition of vCluster will focus on Sveltos and how we are planning to integrate vCluster with it and how you can use both of the tools for your cluster management. So a bit about the project. So if you want to share how the idea project started and where the project is right now, it will be awesome.
Yeah, absolutely. It started over 3 years back. So I've been thinking about it like even for a few months before I even started coding on it. I was working on a project to create on-demand cluster using physical servers. And we had different Kubernetes controllers to manage from the management cluster various things from CNI to storage. And one thing I noticed is that we were repeating like the same code over and over in all those controllers to deploy something on a subset of the clusters that we used to manage. And that's when I came up with the idea of developing something that will address that problem. We were using Cluster API, but Cluster API is great to create, upgrade, and destroy a cluster, but it had limited support for deploying applications on those managed clusters. And that's when I started pretty much with Sveltos. So the goal of Sveltos is to be able to reduce the amount of configuration that is needed to configure like many managed clusters. And while running from the management cluster, deploy anything that is needed to be on those clusters, whether it is an Helm chart or YAML or JSON, whatever.
That is interesting. And what are the couple of most common use cases that you are seeing that people are using Sveltos for?
It takes a different approach compared to just GitOps. And so it has the ability, for instance, to define what you want to be deployed as a template, and then fetch resources from the management cluster at runtime to instantiate the template. This allows, for instance, to easily do things like I want to deploy these Helm charts, but in staging, I want to have a slightly different configuration than I have in production. You can use a single cluster profile. Cluster profile is one of these Sveltos CRD, where essentially you say, those are the set of clusters that are a match using a cluster selector, and this is what I want to be deployed. So using a single cluster profile, you can express what you want to be deployed, and you express as a template. And then at runtime, Sveltos fetch information from the management cluster and instantiate the templates with that information. And this allows, honestly, to reduce the amount of configuration by a ton. And it has also an event framework which allows you to do on-demand deploy things in response to events. So if something happens on a cluster, in response to that event, deploy something else. For instance, if a service of type load balancer is deployed on a cluster, I want to deploy a network policy which exposes this service also to other clusters and create maybe a selector-less service in a subset of the cluster that I'm managing. So even pod there can reach this service. So I think the combination of those two things is what really differentiates Sveltos from any other solutions that I'm aware of right now, open source solution that is there. And that's where I see people are really using it.
And I think you can also use as a central plane to manage clusters in different infra, like your private host as well as your public cloud, something like that.
Yes. From Sveltos, it has I would say at this point, Sveltos has no requirement, because essentially you can manage clusters which are anywhere in the cloud or on-prem. And Sveltos has two modes. It can work in a push mode, where essentially from the management cluster has access to your managed cluster and can configure things in your managed cluster. But right now, also, if you have a managed cluster which is behind the firewall, you can use a different setting in Sveltos, which is the pull mode, where essentially it's an agent in the managed cluster fetches the configuration that needs to be deployed from that cluster, from the management cluster. And so, at this point, I would say there is no really any clusters. It can be managed by Sveltos.
Awesome. And like, for example, how does the internal connection happens? Like, if I want to connect GKE to Sveltos, so how does that connection happen? Like, do you need to install something in the host cluster, or what is it?
No. Yeah, that's a good question. So the default mode is the push mode. When you are in push mode and you have, for instance, in your example, a GKE cluster, you just need to get a kubeconfig to access this GKE cluster. And then you go to the management cluster and you say, okay, I want to register this GKE cluster and I want to call it, you give it a name, you pick a namespace where you want to store your GKE cluster, and you pass the kubeconfig to access your GKE cluster. And from that point on, Sveltos can manage it. Now, most of the time, with GKE, I think the expiration time when you create a kubeconfig, it's probably 48 hours, or even like 24 hours, because what it is. But Sveltos has a mode where it can automatically renew the token before the token expires. So once you register your cluster, then you don't have to worry about that anymore. Like, Sveltos will keep periodically renewing the token and generating a new kubeconfig with a newly generated token, and so that the connection never expires. If your cluster instead, if you have an on-prem cluster which is behind the firewall, the process instead is slightly different, because in this case, pretty much from the management cluster, you cannot directly access your managed cluster because there is a firewall in the middle. So what you do in this case is that you go to Sveltos, so to the management cluster, and you say, I want to register a cluster, but this cluster is going to be in pull mode, meaning I'm not going to give you the kubeconfig. And what Sveltos does, it creates a set of resource on the management cluster, service account essentially, and RBACs, and then it gives you back a YAML. This YAML contains the installation of a Sveltos agent. So now you take the Sveltos agents, you deploy to your managed cluster, which is behind the firewall. Now, once this agent comes up, it reaches back to the management cluster, and then it establishes the connection. And from that point on, any configuration that he has to deploy, he can deploy.
Okay. And the agent is deployed on a cluster level, right? I think it's a pod or something like that.
Yeah, it's a deployment with one replica. Yes.
Okay, so it's a deployment that makes sure the connection and everything is working for pull mode, right?
For pull mode, yes. For push mode, you don't have to deploy anything in your managed cluster. Sveltos, you just have to tell Sveltos this is the kubeconfig to access the managed cluster, so your GKE cluster, and then Sveltos takes it from there. And if you run Sveltos in agentless mode, there is nothing that belongs to Sveltos that is deployed on your managed cluster in push mode. In pull mode, clearly, pretty much at least the one agent is it's required.
Awesome. And so, what are the new trends that you are seeing in this infrastructure, multi-cluster management space? Like, there are a lot of trends in AI, ML, and all this stuff. So, what are the new trends that you are seeing that Sveltos is trying to focus on as well. Is there anything like that?
I mean, from what I see from how medium, large companies use Sveltos, it's mostly to be able to use a Kubernetes approach, also to manage the application and add-ons that are deployed in those clusters, because at the end, Sveltos is just a set of Kubernetes controllers where you select your cluster with a Kubernetes label selector, and then Sveltos does the job. It's the number of managed clusters that are managed by a single instance of Sveltos. It's increasing today. Like I noticed from the telemetry data that one customer is at 126 managed cluster by Sveltos, plus the management cluster is 127 clusters that are managed by a single Sveltos instance. I guess. I will say again, like it's mainly the templating at the agentless mode and this ability to manage like clusters anywhere, cloud, edge, on-prem, that really makes Sveltos a good solution for some folks.
Awesome. So the ability to manage clusters across any environment and the agentless mode are something that are the most popular things by which people prefer using Sveltos, if I'm not wrong.
Yeah, the agentless mode, it's one mode where essentially Sveltos does not put any agent on the managed cluster. And this it's used quite a bit because essentially sometimes you manage those clusters and you give them, there are other cluster admins that have access to your managed cluster, so you don't want them like to, you want them like to be able to do whatever they want to do, whatever they have to do, but you still don't want to lose control of this managed cluster in the sense that you don't want them like to delete the agent on those type of stuff. So it's from the management cluster, you still have full control of the cluster with Sveltos. It has a drift mechanism as well that it's also used quite a lot, where essentially when you tell Sveltos to deploy something, then it starts watching the resources that he has deployed. And if something changes, then it detects this drift, this configuration drift, and override the drift. So making sure that whatever is your desired state, which is defined in the management cluster, it's actually the state of your managed cluster. It does a little bit more efficiently, I will say, compared to other solution, because again, it's even if you lose connection with the managed cluster for a few minutes, when this connection reestablishes, Sveltos is capable of detecting whether something has changed even in that interval that you had no connection to the managed cluster, and only act if something really changed. Otherwise, pretty much it will be like a knob. So that it's quite efficient, because I've heard like many times that from different people that they lose connectivity to the managed cluster for a few minutes, and then, a lot of, when the connection gets established back, a lot of things happen, which, it's not efficient, because it makes your API server unstable. If you start doing like a lot of reconciliation and updates.
And can you basically upgrade and update the clusters as well with Sveltos, like managing the lifecycle of the clusters with Cluster API maybe?
So because Cluster API can programmatically, because Cluster API has a Kubernetes approach to manage clusters, you can use Sveltos to programmatically create the cluster API resources that are necessary to create a cluster. And so, for instance, I have one demo where I show that based on one event that Sveltos detects, a user logging in, Sveltos reacts by creating the cluster API resources that end up creating a cluster on AKS on AWS. I used AWS in that example that creates like AWS. So while Sveltos does not directly create cluster, if you are running on a management cluster, if on a management cluster you have Sveltos plus cluster API, or for instance, any other solution that can manage programmatically Kubernetes clusters, then you can use Sveltos to create those resources, and then cluster API will respond to creation of those resources by creating the cluster.
So someone has commented that it is a lot similar with Terraform. So like if you can share a bit about how different it is, it will be awesome.
Yeah, it's a good question. It is different because it's a set of controllers running on the management cluster. So you can really say that you're using Kubernetes approach to manage applications which are on a cluster. Because it runs on the management cluster, you can watch for configuration drift and react to those. Because it runs on the management cluster and it has an event-driven framework, you can tell Sveltos to watch for events on any of the managed cluster or the management cluster itself and react to it by creating and deploying other Helm charts or YAML, JSON, Kubernetes resources. So the approach is different. When you use Terraform, it's running outside all of your cluster. And with Sveltos, you can say that your management cluster is the place where you define your desired state, and the Sveltos resources, so the Sveltos spec resources, is what define your desired state, and then it's just a Kubernetes approach to making sure that your desired state, no matter what happens, it's always honored. If something change, the usual Kubernetes approach, the new reconciliation happens, and it brings the system back to where you want it to be. And so you can see Sveltos as just a set of Kubernetes controllers that can do this across a fleet of Kubernetes clusters.
Awesome. So yeah, so that was a lot of good questions about Sveltos, and every technical audience loves a demo. So we will go dive into the demo in a bit. But before that, today, what we are going to do in a demo, I will let Colin talk about that. So what are we cooking today, Colin, for the demo?
Yeah, sure. So we're actually going to be using the event framework that Luca just talked about. So we have a managed cluster running in kind, and then we have, or a management cluster running in kind. We have a managed cluster running in EKS. And what we're going to do, we'll set up Sveltos in the managed cluster, the management cluster, and then we'll deploy some cluster profiles, some event sources and event triggers. And those will listen to events on the managed cluster, the EKS cluster. We'll then run a Helm chart against the EKS cluster that will stand up some load balancer services. There's nothing behind them yet, right? So just the existence of the service is going to be the event source that Sveltos listens to. And that's going to trigger some resource installation in the managed cluster. And Sveltos is going to install vCluster instances in the managed cluster. And then it will register. So Sveltos has a registration workflow. It's going to automatically register those vClusters as managed clusters. So it's standing them up and it's registering, and it'll be able to manage them from there on out. So that's what we're doing today.
Yeah, so it's a big and important demo because a lot of teams requires having FML clusters and testing environments. So if you are unaware what vCluster does, so vCluster is an open source project like Sveltos, and it focuses on creating quick clusters for you. So what we do is like we create a virtual API server so that all the requests goes through that, and any resource that you create on the virtual cluster is synced down to your host. So you get quick clusters that you can share kubeconfig with your teammates like we are doing right now. And then you can use that to save costs on your control plane and other specific features like sharing the CREs. Suppose you are using an ingress controller, then you can share your ingress classes to the virtual cluster and ingresses back to your host. So you have a central management layer. So yeah, so let's get started with the demo. So for the demo, I have a couple of things set up. So I have a EKS cluster set up on my host machine and connected and everything. So let me just share my screen. So yeah, so let's yeah. So I have a okay. So this is a kind cluster. So we have a EKS cluster setup over here. I think the font was too big. Yeah. So we have a EKS cluster setup over there, and we have kind cluster as well. So 2 clusters set up. So now I think there is a repository which I will put a link to in the comments. So you all can follow along with me. And there is a YouTube video as well, which we will be pinning in the comments, so you can follow along later on. So let me just add a comment. Yes. So you can go to this repo. But what are the next step, Colin? Now we have a EKS cluster setup.
Yeah, so if you open the repo to the README, we'll now need to make sure that the default storage class is set in EKS, right? So EKS doesn't come with a default storage class. We're going to set that, right? It has the GP2 storage class set up automatically as part of the OpenTofu configs that I shared for Terraform.
Yeah.
Right. So if you
that has been
run
done.
that command. Oh, you did? All right.
Yeah.
Perfect.
Yeah, really done. So give a bit of more intro. So what I did was I created a EKS cluster with the OpenTofu, and then I set up the storage class, so that because we need that for the default storage class to provision vCluster. So those two has been done already.
Perfect. Yeah. So now we'll move on to the next step, which is we're going to register that EKS cluster. So there's a script in this repo, create SA token. What that will do, it will create the service account that Sveltos is going to use, create the secret for it, and then export the kubeconfig into sa.config. So if you run that, that will generate your kubeconfig for you.
So what is
create SA token?
So we are generating a service account. Okay.
No.
So I need to. So the thing is, we are using a. So Rippling has a SSO configured and everything, so the token expires every 10 minutes. So I need to just go and do one step in the background.
Sure.
So this step is not required generally, but this is something I have for my ephemeral environment.
Yeah. Also, if you're on VPN, I had trouble with some of the steps in this README. So what your network connection looks like.
It's not on a VPN.
That's good.
I think. Yeah,
right.
so I think everything's here.
Yeah, so you should have a file called sa.config or sa.something.
Admin.config.
Admin.config, that's it. All right, cool. So from here, right, you can run Sveltos Cuddle. There's a command in the README that you can copy. Sveltos Cuddle register cluster. Right, that'll register your cluster with Sveltos. You want to run that against your kind cluster.
Okay, so we need to set change the context.
Yep. change the context to your kind cluster. So we're going to be shifting context back and forth a couple times.
1 second. Okay. So let's run it. Do we need to change? And I think we need to change this, right?
Wait, just real quick, we want to make sure. Did you install Sveltos yet in this kind cluster?
No. So we need to use
right.
this. Yes.
So there's a Helm command or a list of Helm commands at the top of the README, right?
So this one.
Yep.
And do we need to name it as management as well?
No, probably not.
Okay.
I don't think so. We're going to find out, but I don't think so.
So I think after this we need to label it as well.
Yep.
Oh. This is an interesting error. It's a warning only though.
Yeah, I'm not sure what that's about.
Yeah, this is the first time I'm seeing this.
It does take a few minutes because there's quite a few images to pull.
Yeah. So this kind cluster will act as the management cluster, right?
That's right.
Yeah.
Really, the only reason I chose EKS is because I know it'll stand up a load balancer when you deploy a load balancer type service, right? It stands up in ELB. I have since learned that Azure does as well. I don't know if GKE does or GKS.
Yeah, I think all of the cloud providers do it.
Right.
As far as I'm aware, this was my second time setting up a EKS, so it's installed. So
Cool.
let's label it.
Yep.
Yeah.
Perfect.
Now,
Do you wanna? I just want to add like some clarification on what the last command was. Essentially, when you deploy Sveltos, as you did on the kind cluster, Sveltos automatically registers the cluster that is running as one of the clusters that you can manage. And the Sveltos cluster called management in the management namespace is this cluster here. So what you just did, you just label that cluster with the Sveltos cluster management.
Yeah. So now Sveltos knows this is a management cluster, right?
Mm-hmm. So any cluster profiles that are looking for that label are going to apply to this management cluster, and we have a few. All right. So now we come back to. So you're already configured against the kind cluster, so you can run that Sveltos register cluster command.
Yeah, but what should be this? It should be something else, right?
Yeah. So as far as I know, you can name it whatever you want. Right.
Okay.
So I named it that because this is a vCluster demo running in EKS, but yeah, you can name it whatever you like.
Sure. So this is the namespace, the cluster kubeconfig, which we have generated, and the labels.
Yep, and you'll notice the vCluster equals host. That's the label that some of the cluster profiles are going to be looking for that we're going to deploy into this management cluster.
Sure, and this should be on the kind cluster, right?
Correct. You might have you might have a trailing space after the cluster slash. Yeah, that's not ideal. Sorry about that.
Yeah, no worries. Let me just put it over here and hopefully get rid of that. Let's see.
All right, perfect. So now let's go back to the README, and we're going to apply the resources in two folders here. There's a folder at the root called Sveltos resources, and in there is LB, and those are event sources and event triggers. So those are custom resources as part of the Sveltos project, event sources and event triggers. Those are going to be listening for the creation of load balancer services in the managed cluster, right? And then the Sveltos cluster, Sveltos resources / vCluster folder, right? That's where we're going to be actually deploying out and registering the vClusters.
Yeah. So to clarify, event sources are the like, for example, something is happening, and event triggers are when something is happening, what will be happening, right?
Yeah. What are we going to do in response to the thing that happened?
Sure. So we need to go and apply those.
Yep.
Yeah.
And these are in the kind cluster. We're doing this.
Yes. These are on our kind cluster. So there is an event source trigger, a config map, and the event source trigger. So we are doing two event sources.
That's right. So you're going to first stand up the vCluster when a load balancer service is created. So that's the first event and response. And then when the vCluster is stood up and a secret is created and added to the managed cluster, then we're going to register that vCluster with the kubeconfig for the vCluster as the secret. So we're listening for a load balancer service, responding by standing up vCluster. Then we're listening for a kubeconfig for each vCluster, responding by registering that cluster.
Awesome. So breaking down into these.
Yeah. And then we'll go from one managed cluster to 4 because there's 3 vClusters that we're going to stand up.
Yes.
All right. So now you got to switch your context back to the EKS cluster. And it might have been 10 minutes, so you might have to re-authenticate.
I hope not. Let's see.
Yeah.
All
right, perfect. So now you'll run that Helm command, Helm upgrade install developer load balancers, and there's the local charts folder. Yep, there it is.
And what do we have in the charts?
So the charts, this is really just standing up. If you look in templates, it's standing up just a load balancer service for each developer listed in values. So I've put 3 developers' names. They're not real people. It's just made up names. And so for each one of them, we will get a vCluster.
And then if we reapply by removing or adding a developer, then one more vCluster can be removed and deleted, right?
Yeah. So when I was testing this out, I added 2 more people just to see, hey, make sure this works as I think it does, and it worked. It added 2 people. So
Yeah.
and that's so Helm is basically standing up a load balancer per developer, right? So you add 2, you add 20, doesn't matter how many. Each person will get their own vCluster. Coupled with Sveltos.
And the developers can use that load balancer to authenticate to those specific vCluster for
That's right.
their operations. So
yeah, that was why it was important for some cloud provider to provide the actual ingress, right? The physical ingress into the cluster, so that once the vCluster is set up, that service is accessible from the internet, right? So that the developers can actually access it.
Yeah. So
if we go back into your terminal, you should be able to kubectl get pods in all namespaces, and you should see, prove me right, you should see everybody does, yep. So you have managed vClusters there. Ringo, Arvis, and Gunther all have managed vClusters.
Yep.
And if you switch back to your kind cluster, you should be able to get the, you should be able to kubectl get, is it clusters? Okay. Sveltos clusters.
Sveltos clusters.
Yeah. And there they are, right? They're all managed. They were all registered automatically.
Oh, yeah. Great.
Right. And it takes a minute. I think roughly about 2 minutes for them to come online, but they're registered. They're ready to go.
So next, what we are doing over here?
That's it. Those vClusters they can be managed now, right? So any cluster profiles you want to apply to those vClusters, or any cluster profiles you want to add in Sveltos, Sveltos will then install whatever applies to those cluster profiles in those vClusters. So they're managed the exact same way that the ZKS cluster was managed. So let's say, for example, Gunther is a data scientist. You want to install Kubeflow, right? You would apply a cluster profile with Kubeflow, and that would automatically apply to, what was it, Gunther's vCluster. Arvis, on the other hand, is DevOps engineer, so you can deploy Argo, so we can play around with Argo. However you want to manage it, right? Sveltos is now your control plane for managing all those installations in your vClusters.
And what if I want to get inside the vCluster? Like, for example, I'm Ringo. So how do I get the kube config so I can use it?
Yeah, so in your EKS cluster, those kube configs were set up as secrets. So the creation of those secrets was what Sveltos was listening for in registering the cluster. So it took that secret, read its contents, and applied it as a kube config. You can do the exact same thing. Right? You can take the secret down, share it with Arvis, Gunther, or Ringo, or yourself, and you'll be able to access the vCluster directly.
And now, suppose if we want to remove, we want to, like, if Arvis is leaving us, so if we'll remove this and apply it, so the cluster will be deleted.
Yep.
Let's try that.
So far, I hope it works this time. But yeah, every time I've tried it, yeah.
So
you'd Helm upgrade with that values, and it should work.
Okay. So
I think you might be running against the kind cluster. You want to configure against the EKS cluster.
correct. Yeah, revision 2.
Perfect. So
And
now if you get pods, you should see, who do we remove? Gunther? Here we go.
Oh God,
Someone's is getting destroyed.
last one. Who was the last one? Arvis.
Arvis. Arvis is losing his vCluster.
Yeah.
Still
So
running.
let's
It takes
see.
a second.
Yeah, of course. There are some legalities and everything that needs to be get done.
And let's just make sure by running. Let's see if it works this time. All right, he's gone. Good.
Yeah, and now if we switch back to our kind cluster and get Sveltos clusters, it should be not be there as well, right?
That's right.
Yeah.
The
Not
demo
there.
works.
Yeah,
Couldn't
the
be
demo
happier.
So like that, if you have 10 more developers joining in, 10 more developers leaving, so you can manage everything from your central plane, and without waiting long provision time, which generally takes with creating a new EKS cluster, you can use the power of the cluster to create things quickly.
Mhm.
Yeah.
Yep. And there's a
And
bunch of
also,
different ways you could extend this demo, right? You could use GitOps to actually manage your deployments. So every time that values YAML file changes, you can apply it there. There are ways you could extend this so that like your target cluster isn't necessarily the one where you stand up your vClusters. If there's like a developer cluster somewhere else, right? There's a lot of different ways you can extend this. Or if you want to try this without standing up EKS, you could do this technically with kind. You just have to install a load balancer. But what you see now, so before when you first ran get Sveltos clusters, they didn't all say ready. Remember I said it takes a second for them to be ready. Well, now you can see they're all ready.
yeah. So yeah. So it's nice the demo worked so simply without us trying to figure out things and without to re-authenticate with the EKS. So that is also a good thing.
That is good. Yeah.
And another use case that I was just thinking about this one, I assume that pretty much you want to not just create a vCluster, but create a vCluster with a set of applications and add-ons which are consistent. In the first step, the first event, when the Sveltos cluster is registered, you can just, that event can create a Sveltos cluster with a predefined set of labels. And so if you have a predefined set of cluster profiles with a list of applications and add-ons that you want on those vCluster, as soon as the vCluster is created, Sveltos detects it, and then all those add-ons will be deployed. And so they will be deployed. They will come up with just all the applications that you need. So it's pretty good use case.
Yeah, that is quite nice because you can templatize everything and your developers can go and run things faster without like for example with vCluster as well. It is a good use case that if you have ingress controllers defined on the host and Kaizen policy everything configured on the host, then any cluster that you are creating, if the sync is enabled, developers can use it out of the go without trying to figure out everything in the background and why things are not working. So yeah, apart from that, I don't see any questions right now, but thank you so much for being here and accommodating last week. So it was awesome. It was awesome doing such a interesting actual use case demo, where a lot of demos are simple hello world, but this was a demo in which people can actually go and get benefits from it, as this is a very common use case to have fast development environments and managing everything. So there is one question from Penguin Mind. So the question is, infrastructure bootstrapping GitOps, can I bootstrap Argo City with Sveltos? So if you can.
Yes, you can. Essentially, when the vCluster, when any of those vCluster is created, you can create, before you create any vCluster, or it doesn't matter actually when, but if you create a cluster profile where you say like, this is the Argo CD configuration that I want to be deployed on all vClusters that are created and labeled with, I don't know, with Argo CD require label, then as soon as those vClusters are created, and Sveltos detects that to the using pretty much what Colin did, then Sveltos automatically will deploy Argo CD in each one of those clusters.
Awesome.
Yeah, I just to be honest, I don't really install things anymore. I just have cluster profiles for anything that I want to play with, like Argo CD, NATS, Envoy Gateway. Like I just have a cluster profile for all of them, and I have a kind cluster that manages all my stuff whenever I'm playing around or at work. We use Sveltos as well, so we have a management cluster that manages everything. So yeah, you can bootstrap whatever you want. It's pretty cool.
Yeah. So thank you, folks, and see you in KubeCon North America. Hopefully.
Yeah, looking forward to meeting you in person.
Yeah, thank you so much, and thank you for being here at this episode of vCluster Friday. Bye.